Netflix. It's a platform that you've probably spent a lot of time binge watching your favorite TV shows and movies on. But Netflix actually wasn't always conducive to binge watching. It started as an answer to Blockbuster Video, which was a company that rented out movies, TV shows, and other DVDs to customers through physical locations hosting a catalog of movies and TV shows. And so for each rented DVD, the customers would have to pay a fee and they would be able to maintain that rental for a set period by Blockbuster. And for each day past the deadline that they need to that customers need to return the DVD by, Blockbuster charges a late fee for each day, equivalent to the cost that the customer had to pay to rent out the DVD. And so Netflix's answer to this was to create an internet-based application where customers could rent out movies, TV shows, and other DVDs online. They didn't charge any late fees and they didn't charge per DVD and instead charged a monthly subscription fee. And to mitigate the potential issues caused by not having late fees, Netflix would instead just prevent users from being able to purchase new rentals until they had returned the one that was overdue. So, from a unit economics perspective, Blockbuster clearly is far more profitable per DVD compared to Netflix because they're charging for each DVD that's rented out, along with subsequent late fees that probably were very easily accrued due to customers needing to go physically um, to return their rental. Versus Netflix, customers could rent out 10, 15 movies each month and only pay one monthly fee if they're returning everything on time. But why? So then why did Netflix still win given that profitability issue? That's where Blockbuster made a critical error of downplaying the internet and the convenience of Netflix's services. Netflix provided a far more pleasant user experience by not forcing customers to go physically to purchase rentals. They charged a monthly fee instead of per film, and people could do it from the comfort of their own homes, along with not having to deal with the overhead of shipping costs. And Netflix also provided a recommendation algorithm, so customers wouldn't have to spend so much time trying to ask a Blockbuster employee for recommendations that they might not know much about themselves. So inevitably, Blockbuster ended up losing. And Netflix's system was just far more scalable as well. Blockbuster, in order to scale, would need to open a new physical location, hire new employees, and that just comes with a very high upfront cost and overhead associated with it. And then having to stock that entire store with all of their movies, it's a very arduous process to scale for Blockbuster versus Netflix only really needed to maintain and grow their large library of uh, movies and TV shows, video games, along with ensuring that their transportation systems were efficient, which USPS uh, already had a very robust system that they were using. And they just needed to maintain their warehouses, and it was just far, far more scalable. It's much easier for a Netflix customer to be acquired and maintained as opposed to a Blockbuster customer who probably would not have that pleasant of an experience with Blockbuster's system compared to Netflix. And so Netflix became a Goliath, and Blockbuster ended up inevitably dying and going bankrupt. And Netflix had positioned themselves very well for the revolution that was the wide accessibility of broadband internet, along with the increasing popularity of video streaming. Before we talk more about video streaming, I'd like to give an overview of how the internet works. So, the internet consists of routers, links, and end systems. So end systems being things like servers where data is hosted, or things like your laptop. So this is a laptop, let's just say it's yours. This is an end system. This is a host, for example. And let's just say I want to make a request to a server located somewhere else. This request is accomplished through something called a packet. A packet is essentially a data that contains a header with an address that will lead to where you're trying to reach. And this packet will travel through the internet's core, so all of these links and routers, and eventually reach the point that you want, the server. So the way that it works is you have these routers that extract information from your packet and relay them to other routers. And as this is happening, you're going through these internet service providers, which are the bridge between your edge systems and the internet, essentially. This is how you're able to connect to the internet on a global scale. So these ISPs, are, as they're called, are connected to other ISPs, and they form a sort of hierarchy where some ISPs are local, they're close to your home, they're regional. These are tier three. Tier two are more national, so there aren't as many of them, and they kind of bridge the gap between major cities and major hubs. And then tier one ISPs are essentially international bridges. They are the gatekeepers between international packet switching and edge devices. So it'll travel through this network hierarchy and reach this end system, and then the data will be relayed back. So this doesn't necessarily happen in order. Um, it's based on a process called statistical multiplexing, which essentially analyzes the conditions of the network, the properties of the packets being sent, and optimizes the system so that everything is sent and received as fast as possible. And so that one computer isn't just hogging the entire available bandwidth of the routers and the other components of the internet. Bandwidth being the amount of packets, the size that can be sent from one router to another, like how much available space is on the link, essentially. And so, diving into the details of the network hierarchy a little bit more, there are tier three, tier two, and tier one networks. And the way that it works is that you need global connectedness, but the way that you do this is you have the tier three networks connect to tier two networks, connect to tier one networks that give everyone access to what they need access to. Um, but when you have a customer ISP, for example, a tier three ISP, connecting to a provider ISP, a tier two ISP, because the tier two ISP is essentially the gatekeeper of the data being able to be transmitted to another area, the customer ISP will need to pay a transit fee for the data packets that get sent over to the tier two ISP. And this is why we have IXPs, as you can see here. These IXPs help ISPs of the same tier connect to each other so they can minimize the transit fees that they pay to tier two ISPs. Let's just say you have a situation where you want to reach some edge device. And these edge devices are connected to two tier three networks. And so an IXP would connect these two tier three networks to one another without having to, so they wouldn't have to pay any transit fees because you can reach this edge device through a link between these two tier three networks, as opposed to needing to go to this tier two ISP and then wasting money because you could have done it through these tier 3 networks instead. So now that we understand how the internet works at a high level, let's start to dive into the details of content delivery networks and video streaming on demand. So, for context, a video is essentially a sequence of images that can be anything from 24 to 240 frames per second. A frame being a set, an image essentially, consisting of a massive array of pixels. And each one of these pixels is essentially an RGB uh, code to show what color should be, what the color should be. So each image is basically a pretty significant amount of data. Each video is a lot of data. This adds up very quickly. And so video compression, chunking, and adaptive streaming are crucial to mitigate the networking nightmares that can happen as a result of video streaming. So the way that compression works, at a high level, it uses a process called group of pictures. So GOPS for short. And what group of pictures does is it consists of iframes, and then B/P frames. So an iframe is essentially the whole image. And the PB frames, they are they use these iframes as a reference point to essentially show only the change that happened from the original iframe. And these happen this happens in chunks. So iframe, you have an iframe, and then you have a bunch of P, P, B frames, and then you have another iframe. So this is a chunk. And so the way that it works is that these iframes capture the original image unchanged. So let's just say you have a person and you have a tree. I'm not a very good artist, but and then this is an iframe. This is also the same image. The P frames and the B frames will show only the change that happened in the next scene. So the next iframe is, let's just say, the person moved away from the tree a little bit. The P frame won't include the tree in the image. It will only include the change that occurred from the original iframe. And this saves tons of space because frame to frame, not much change is happening. So you don't need to store as much data as opposed to if you just had a ton of iframes. And so adaptive streaming will request the best version of each chunk that it calculates as possible based on the available bandwidth. So, for example, if you have a group of pictures, and this group of pictures is in 4K, um, 4K, these group of pictures will last for 8 to 10 seconds. And then once you reach the next iframe, once you reach the next chunk, you will then have a potential issue of loading because the system needs to readjust itself to account for the bandwidth that potentially may have decreased due to high network traffic. So that's why you can only really go up to a certain point in a video when you're watching it, if it's a really long video. So this combination of video compression capabilities and just the widely accessible broadband internet really made Netflix's on-demand streaming platform skyrocket. And as Netflix's popularity grew, they started to have to rely on third-party content delivery networks, which are essentially ISPs that are dedicated for delivering content. So things like YouTube videos, Netflix movies, all of that kind of stuff. And so as Netflix's popularity grew, they started to use third-party content delivery networks help them manage all of the traffic that they were gaining. And so these tier one ISPs became pretty unhappy because Netflix was taking up the majority of their traffic and causing them a lot of bandwidth issues and network congestion issues. There was just way too much traffic volume, and they were very unhappy. They wanted these third party CDNs and Netflix themselves to cover the transit fees in addition to what they were already paying for upstream delivery. So yeah, with the bandwidth issues, the high networking costs, and Netflix kind of being viewed as a freeloader by these companies. And so Netflix needed to address this. And what they did was essentially create their own content delivery network by placing thousands of caches across tier two and tier three internet service providers to avoid the costly transit fees that the tier one ISPs were trying to make them pay. And this was great for Netflix because it gave them far more leverage, and it also improved their performance for users. Because these caches could send data so quickly to their users and they were so large, users just had far less bandwidth issues and delays in their streaming time. And by keeping the content closer to users and having control over those caches, Netflix can push content that they know will be popular, like Stranger Things season 5, into the caches. And this prevents the need for so much upstream network communication to occur. So Netflix controls what's pushed to users and cached. Popular shows, things that pop up on your recommended, and things that you're watching frequently. It's a really, really smart system that eliminates a lot of overhead for Netflix, as well as the tier two and tier three ISPs themselves, because this is free hardware for them. They don't have to send as much data upstream. They can store data locally on their own in their within their own system through these local caches, and it just reduces their transit fees, and it's a win for everyone. It was a really, really innovative solution to this issue. So streaming today is highly fragmented, as everyone knows. There are so many different providers now: Disney Plus, HBO Max, just to name a few. And that begs the question of how they handle networking. So let's give Disney Plus as an example. Disney Plus didn't do something similar to Netflix by creating their own content delivery network. They instead used multiple third-party content delivery networks and switched them based on the available bandwidth, the performance, and this is much more effective now because the multi CDN system is much more mature now. There's better providers, the cost is lower. Um, if Netflix wanted to do something similar in the past, they would not have been able to afford it. And so, in terms of what Netflix is doing today, something that they've innovated on recently is creating per title encodings. And what this means is that instead of having a fixed bit rate like they did in the past, Netflix now has uses less bit rate for less complex and lower bandwidth shows. For example, BoJack Horseman, there's not too much going on. The data is not as large versus something like Altered Carbon is far more complex and will require much more bits to be transmitted across the networks. And they've even started doing this shot by shot. So they can analyze the complexity of a shot and then determine how much the bit rate should be for that sequence of frames. And that's everything. Thank you for taking the time to listen.